In this video, we'll discuss logistic regression in PyTorch. In particular, we're going to talk about prediction. First, we'll talk about the logistic function. Then we'll talk about a cool module called NN sequential, and this is a great way to build a really fast model. And then we'll talk about building a custom module using nn.modules. In logistic regression, we have a linear function, and instead of the output being denoted by y, we'll denote it as z. We pass the output of z to the logistic function, and then we get our estimate y hat. We can also apply it to vectors, where instead of multiplication with a dot product, but the output is still one-dimensional. First of all, let's talk about two ways to make the logistic function in PyTorch. So the first way is using the module torch.nn. So let's create some data, and we use the object constructor nn.sigmoid. And this creates a sigmoid object. And then we can input our tensor to the sigmoid object, and we get our actual estimate. And there's a plot of it over there. We can also use the nn.functional module, and it's common practice to import it as f. So we have our same input tensor. And in this case, sigmoid is an actual function. So we input our tensor, and we get an output, and we can plot the output. So now let's talk about the first way to build a logistic regression model. And this is NN sequential. And this is a really fast way to build a model, but it's not as flexible as using nn.modules. So we have our linear constructor, and then we have our sigmoid constructor. We have a one-dimensional input. So we use a sequential constructor to produce our model. And the first input is a linear constructor, and the second input is a sigmoid constructor. And then we can produce a model. And what this will do is we'll take the tensor x, produce the output z, and then pass it to the sigmoid function, and we get our estimate y hat. We can also build a custom module. Here's our custom module. It's pretty similar to linear regression. We construct our linear object using the constructor. The only difference is our output, we have the sigmoid function. And this will apply the sigmoid function. So we'll create an object using the constructor. In this case, our input dimension is 1. And this will produce a linear output and then apply the sigmoid function to it. And that's our new output. So let's see how to make a prediction. So we'll create our model using a custom module. An nn.sequential module will behave the exact same way. The input is 1 for both cases. So we can see our model parameters, and they have the following correspondence with the closed form. Let's input a tensor of 1. We apply the model. It applies a linear function, and then applies a sigmoid function, and we get an output. For multi-dimensions, it behaves a similar way. We create the model. It applies a linear function to each element of the model, and then applies a sigmoid to each element in the model. And there's a correspondence with the linear function on the left. Let's see what happens when we have a multi-dimensional input. So the model behaves similar to linear regression with a multi-dimensional input, except we apply the logistic function to the output. So we can create our model using the custom module, or we can use the nn.sequential module. In this case, we'll perform it with a two-dimensional input. We can view the model parameters, and this is the correspondence with the analytical form. We can input a tensor with 2 dimensions, and the model applies a linear function and then applies a logistic function after, and we get our output. We do the same thing for multiple samples, except we apply the logistic function to each output. We have our input tensor. We apply the model. This applies a logistic function to each output, and we have 3 inputs and 3 outputs. And that's it.